Matthew, and our project is about juice jacking. Okay, so what is juice jacking? So juice jacking is whenever malware is installed into like a public charging station, and we all have a phone, and we all need to charge it at some point. And whenever you just go to the charging station and plug it in, the malware can be transferred into your phone, and they'll take all of your passwords and emails and stuff like that, which is pretty dangerous. So the term juice jacking was first coined in 2011 after researchers had an event about the awareness to the problem. So basically, just like I said, they would plug in their phone into a public charging station, and they would get a security warning, which proved that juice jacking was actually a thing. So our problem statement. So over the last 5 years, travelers charging their mobile devices in airports around the world, they've been targeted by hackers and scammers. It's been shown that malware and viruses can be transferred via a public USB port and affect your devices when used. So we conducted a survey here at Hillcrest that allowed teachers and students to answer it. We got 43 results, and out of the 43 people that answered, most of them used public charging stations in hotels, restaurants, airports, and schools. And more than 50% of the people, they had no idea what juice jacking was. And then we asked them if they've ever had a device or an account hacked, and 51% of them responded with no, and 37% of them responded with yes. Out of the people that responded that they did get hacked, more than 50% of them didn't even know how they got hacked, which is pretty bad, So we then asked them how much would they be willing to spend on a device that would block your device from being hacked. And the majority of them, they'd be willing to spend about $10 to $15 on it. But us, we didn't want it to be expensive so that everyone could have one. So this is the first article we found. This is from 2020, and basically what this article tells us is that a USB cable has 4 pins. 2 of them are for data and 2 of them are for power, and only one of them is necessary to charge the device. And you only need 2 of them to transfer data. And in a bit, we'll explain what we're trying to do with it. And this is our second article. And basically what this article is about is in Los Angeles, the county district, they warned the tourists that to be aware to not use public USB charging stations because they fear that they might have maybe gotten hacked, and they were persuading them to use portable chargers or car chargers or AC power outlets. And what this is our evaluation criteria. What this is basically our goal, what we're trying to accomplish. So our first goal is we are trying to get our devices to be integrated into the charging cable. So basically in one piece and not too many loose pieces. And our second goal is we want to have the ability to cycle between power and data modes. And basically for power mode is just some powers allowed, and then data mode is just data. But with data mode, you can also charge your phone. And for our third goal, we wanted to indicate what mode it's on, so if it's on power or data mode. And for our fourth goal, we wanted to be compact and not take up much space. And then for our final goal, we wanted to just function properly in both power and data modes. And this is our similar solutions chart. So basically, we found 3 class solutions. They're all pretty much the same. They're kind of bad. So the red means it's bad, and then the yellow it's okay, it's neutral. And yeah. So for our first solution, it's a portable 3rd-gen USB data blocker, and this one's pretty bad. It's not integrated into a charging cable. It's not able to shift between charging and data. It's somewhat compact and it's somewhat functional, and it's somewhat compact with other devices. And this one, it's the same thing as the other one. It's just a little better, but not really. But so it's not integrated into the cable. It's somewhat able to shift between charging and data. It's not able to indicate what state is it in, so if it's on power or data, and it's not compact.
Yeah, so this is the theory behind our design. So as we talked about, there are 4 pins on a USB input. So you can see from left to right, they go from power, and there's 2 data pins and a ground pin. So the most important part of our device is the fact that you have the ability to disconnect the circuit for one of the data wires. In order to transfer data, you have to have both wires because they work in tandem, right? So we have one switch on the data minus cable or wire, and this enables us to be able to cut off the data transfer. We also have another switch on the power circuit, and this is connected to our LED indicator. One of our criteria was that we wanted the user to be able to see whether or not they were transferring data or not. So we had them connected. We wanted them to be connected using like a double pole single throw switch, which is what is diagrammed there, which basically means there is one action that you can do, and it controls 2 different circuits at the same time. As you can see on the right, we have 2 switches that are single pole, single throw, because we just didn't have the opportunity to find and buy switches that were the correct type. So yeah. So this is a diagram of like an actual USB wire. As you can see, there are 4 pins. They go 5-volt power supply, data minus, data plus, and the ground wire. So we would be interacting with the top 2 ones, the pin 1 and 2. And so that's the 2 wires that we'd be interacting with. So here's like our pictures of the building process. You can kind of see the scale we're working on with like the first and third pictures. So I mean, I used the Dremel basically for the entire thing. And you can see kind of the scale. That's like the tip of the Dremel with a tiny little file on the end. So that's kind of pretty tedious. Something that I didn't anticipate when I was cutting open USB was the resin inside the actual USB. That's the middle picture. That was quite difficult to actually get around. I managed to do it just by filing the entire thing on. So this is like our first kind of prototype, and basically this is all you needed in order to make it functional. You just needed a single wire on, or a single switch on one of the data wires, and that would prevent any data being transferred from one device to the other. And that's kind of what just these pictures demonstrate. So our design process. So throughout the design process, we had over 20 distinct designs that we went through. After each iteration, small changes were made in order to make it functional. And then after we had a version that was fully functional, we gathered the pros and cons of that version and basically started over. And that's how we established the design. So the following versions are the main versions that we did. So this is like the prototype. This is like the very first model that we did. The 3D printed part was really only functional as kind of a way for us to find the dimensions and stuff of the actual USB part and the tolerances that we needed to use. So as you can see, it has a couple cons. It's not compact. It doesn't have an indicator of what mode it's on. But it does have a switch installed, and it does function as it's supposed to. So this is like the first version. It's the same one that you saw earlier. The process version was quick. It was easy to design. and it serves as a starting point for future designs. The cons were the switch did not fit into the slot that was designed for it, and it was not big enough to encompass all of the circuitry that we had installed on it. So this is the next version. It's quite a bit bigger. There are grooves inside that'll enable you to easily remove it. A problem that we had was that we found that like the 3D printing filament is actually kind of slippery, so it can be difficult to remove the USB. So we added the grooves inside. The problem that we had was that there was no way to integrate an indicator LED into the actual device, and that the only way to do this is the only way to install it is by sliding the entire component in, which is not a long-term solution because it takes a lot of time and it's not very secure. So this is our third version. We kept all the pros, but we added some of the cons. So we have a hole in the side that enables you to insert the indicator LED. And we made it so the switch actually works and functions inside the actual device. So the slot has enough space for the USB, or not the USB, for the switch, and the LED light fits into the little hole over there. So the cons of this was the only way to install, again, was to slide the entire assembly in, which is not a long-term solution, like I said. And it's also hard to install the LED indicator based off like how it was, because the entire assembly was rigid, so you couldn't flex it, which made this kind of problematic to actually integrate. So this is our fourth version. This is the first version that we had designed with the idea in mind for like actual production. The first thing we thought of was having multiple pieces. This would enable us to basically assemble the pieces in the outer shell around the main assembly, eliminating the problem of having to slide the assembly into the actual USB shell. The biggest con of this is that there's 3 different pieces, and as you can see, like each different color is a different piece that we have to print. Printing 3 different pieces for one device is it takes a lot of time and it's kind of unnecessary. So we wanted to get rid of that. And another problem we had was that actually gluing the pieces together, which is the method we chose to join them, it was quite difficult because they would move around a lot and you had to keep 3 different pieces clamped together for the amount of time that it took for the glue to harden. So this is our 5th design, our 5th version. It consists of 2 different parts. So we eliminated having 3 and we cut down the amount of parts we have to produce, which makes the production a lot simpler. We also added tabs. That's the little triangle you see on top. There are 2 tabs. We added tabs to keep it in place while the glue is setting, and this makes it a lot easier for the assembler to actually assemble it because you don't have to worry about pieces moving around while the glue is setting. So one of the cons was that it did not fully secure the wiring. So the wiring is like hanging out the back, right? And you can pull the wiring and it would like interfere or completely break inside the assembly, which is not really what you want. So this is our final design. Yeah. So this is our final design. It fully constrains the movement of the wires in the back. That's what the little holes are. We had quite a bit of trouble actually getting the correct hole size because they needed to be like exact. So we printed like a 3D piece that basically just had a bunch of little holes in it of slightly different dimensions, which we tested on the wires in order to find the correct dimensions. So the reason that we have those holes in there is so that you can crimp the wires, which will prevent them from being able to move, and so that you keep all the force of like the tugging on the wires away from the actual assembly on the inside. The biggest con that we had in this device is that it wasn't waterproof, right? So you want your cable to be waterproof in case you spill water or drop it in, like, I don't know, a sink or something. But the problem we had was that we weren't able to like waterproof it because of the materials we had available. So these are some of the drawings that we used, right? So I made these in SolidWorks. We actually were using Onshape, but SolidWorks had better designs for better UI for rendering and stuff. So this is the bottom piece. Yes, this is the top piece. And the next slide is the entire assembly, just so you can kind of see more images of it. So this is our design iterations. These are our 6 major designs. So you can see how we went from like a very basic cube thing to like our final design, which has all the features that we wanted. So this is a pictures of our final design. The centerpiece is the design without the shell, so it's just the assembly with the wiring, resistor, and LED and stuff. On the left, we have just the front view, and on the right, we have the side profile. So we did 3 major tests in order to see whether or not it works. The first one was an LED indicator test. So we reckoned that like the amount of time we'd have this plugged in over its lifetime would be really long. So we wanted to see whether or not like our resistor matched the correct resistance and provided the correct current. And we found that that test was a success. We were able to run the LED for 24 hours straight without it burning out or causing significant heat buildup. The next test we did was a data transfer test. We wanted to be sure that all of our wiring and stuff was correct and all of our soldering was correct and that it actually was able to transfer data. We found that this was successful as well. We were able to transfer data and pictures from the phone to a computer and back. And then the last test we did was data blocking test, which is probably most important. It's what we're all here for. And that's the ability to block data when the data transfer isn't to be prohibited, right? So this was a success as well. When you turned off the data transfer function, the devices will not even recognize each other, and the data or pictures will not transfer. So these are our procedures. I mean, it's basically self-explanatory. But so basically just plugging in the thing and turning on or off the data transfer. So, yeah. So this is like pictures like proof of our success. So this is the data transfer test. You can see we transfer pictures from the phone onto the computer. You can see on the top right, we have the file, the device name of the actual phone we're using. In the bottom right, we have the LED indicator state. It's kind of hard to tell, but the LED is on. In the next picture, you see on the bottom right, the LED is off, right? And we get a message saying the USB device is not recognized, and the phone is unable to transfer data to the phone to the computer, and the computer is unable to transfer data back to the phone. Right. So in our design evaluation, we managed to hit all of our criteria that we set at the beginning. So the device is integrated to the charging cable. The device has the ability to cycle between power and data modes without disconnecting. The device indicates what mode it is on. It is compact and does not take up unnecessary space, and it functions properly in both data and power modes. So future steps. The first step we wanted to do is waterproof the design. So like in every different USB cable, they're all waterproof to a certain extent. One way that we could do this is using like a resin epoxy solution, much like the original epoxy solution that was found in USB. That's an example of the USB epoxy solution we took apart. The next thing we wanted to do was use non-3D printed parts. Like I said, printing was kind of troublesome, especially printing multiple parts and assembling them. So we would like to have used like a injected mold solution or something like that. All right, so the other steps we wanted to do was to finalize our wire management. In the previous pictures, we saw that the wiring wasn't like finalized. There was a lot of loose wiring, and there was like a cable jacket or proper installation on any of the wiring, which was obviously problematic and is in fact a health hazard. This is probably the first thing we would have to get done in order to make this like functionable, because it's the part that's actually dangerous. So we also wanted to finalize the parts. One of the biggest things we needed to change was our switch. Currently, we're using a single pole, single throw switch, which is basically just standard light switch. We wanted to have a double pole, single throw switch, which is a switch that, with a single movement, enables you to control 2 circuits at the same time, and that would control the circuit for the data and the LED indicator at the same time, which would keep them the same.
We would like to thank Ms. Combs for keeping us on task. And we would like to thank Walt Disney Imagineering for providing us with the 3D Dremel printer that we basically printed all of our prototypes and our final products. Thank you.
Great job, Frida. I don't recall, and you were having to march through pretty quickly, so I understand. But I don't recall you showing a version where the data switch was flipped, but you verified that it was still charging.
Oh, okay. Yeah, so we actually didn't have a picture of that. So it does. So I can go back to like our wiring diagram basically.
You don't have to. I was just saying I didn't see one of the.
Okay, I'll make, yeah, so in the future, we definitely should have that implemented.
I did see, it looked like on the picture that you put up there, I thought I could make out a little lightning bolt that on the phone that maybe indicated that it was charging, even if it wasn't an intentional picture. That one right
Yeah,
there, it looks
yeah.
like there's a little.
Yeah, it would charge,
I mean,
but it's very slow because I'm running it off my surface. So.
my question was, would this product have to differ for different brands of phones, Apple or Android, or is one brand more susceptible to the juice jacking, which I learned a new word today. I thought that was some sort of fruit concoction that would really build up your muscles or something. But, yeah, differences between Apple and Android or other brands.
Yeah, so from what I can tell, there's no real difference in like security of the phone, right? So the only difference in our design would have to be using a different cable, but that's not actually challenging because the only thing we're actually changing is the USB-A side. Some cables now use USB-C to USB-C, and you can just charge USB-C into a power outlet. That would be challenging for us because like we're already working on a very small scale of USB-A, which is like much larger than USB-C. So it would be very hard to implement this solution into a USB-A, but it would probably be possible still. We just have to use much smaller materials, and you don't have the access to those.
Thank you for your presentation. I had actually written down, but does the phone still charge when the data is blocked? So that was for sure a piece that was missing since that was the primary goal there. The future step slide, I don't know if you want to go there. This is just for everybody in the room. You want to limit on slides, you really want to limit the number of words because most people are not going to read that. And so, just some short phrases probably would have been good. Actually, the first bullet, like under waterproof, is probably not even needed. The second and third, could be simplified, possibly in there. But I liked that the presentation was very clean, and it was very step by step. I'm a visual person, so I was able to follow that. Another comment is I appreciated the nice renderings, as well as the multi-view with the dimensions and everything. That's really what we want to see, when we're looking at an engineering design project, is those specs. So thank you for including that. And I appreciated the journey through the different versions and the different design iterations. I really enjoyed seeing it evolve. Two last comments in the beginning for your justification. You talked about like people's awareness of, being juice jacked or whatever it's called. But to make us care about this design, we really need to know what are the damages caused by it. So like including some justification, maybe some stats behind how often this occurs, or maybe telling a story about someone lost $5,000, in their bank account because of it. Get us to care about your project. And then the final comment was just, I wasn't real sure on like the roles. So I was curious, and it's a question from you, the first two speakers, because once the design was decided on, pretty much you walked us through it. and it's okay to have rows, but were y'all able to, how did y'all contribute to the design iterations as it went through? And then as well as, you know, like once you tested it in the building of the prototype?
So we kind of like did the slides, which isn't much, but we really couldn't get into the whole like getting into the USB thing because he's kind of an expert on that. But we were there for the process. We watched him and helped him with anything that he needed. And we were there also to test it out with the little phone that we used. But yeah, we were kind of just, we were there, we were helping him, but it's all props to him.
Well, and it's okay to have roles, you know, like if he is the main one that's using the, you know, that's printing it and building it. So I appreciate you being honest, and, you know, giving him most of the credit there on the engineering part. But it would have been nice to hear a little bit of how you guys like maybe question maybe some of his decisions or some of the testing, kind of, you know, because it kind of just dropped off at that, once you had to decide to go ahead. But great work. Thank you.
One other quick question for you guys. You referenced the indicator light a lot. Yes. But you never, I don't remember you saying what would actually cause it to be on or not on.
Yeah, so I can go back to, I guess I didn't do a very good job, but I'll just explain that. So basically, so the second switch, so, right, on the far left side, the first switch is next to the power circuit, right? That comes over to the LED, which is on the far right side, and then is put into the ground. So you can see on our actual picture, there's like 2 switches, and we couldn't get a switch that was just a single pull, single throw, so there were just 2 individual switches. So if you wanted to actually make it correct, you'd have to switch them both at the same time, which isn't that big a deal, but it's still kind of unfortunate. So just switching the switch on the far left would transfer power to the LED indicator, and the resistor that we use would ensure that you weren't cycling large amounts of power and like inhibiting the actual power input to the phone. So yeah, we didn't notice any major difference in the actual charge rate of the phone, so we just didn't. Yeah, and a USB, an LED takes such little power anyways. So.
So how much would one of these cost if I want to buy one?
Yeah, so in total, this would have costed around, like, we didn't buy in bulk, so it would have cost around $3. The switch was like 50 cents, I think, something like that. And the actual wire, we didn't actually buy in bulk. So you could buy one of these wires for like $250 easy. So yeah, the LED and the resistor are obviously very cheap, they're just single LED resistors. So you can buy these for like $3. We, in our actual data collection, people were saying they would buy it for upwards on $15. So we probably settle for around the $5 to $10 range in order to get a larger selection of people. So probably around $10 is what we were aiming for. And you know, that's pretty fair considering, like, you know, Apple charges like $60 for one. So it's not, so.
Yeah.